Number 7 does not look like a exponent problem, but number 7 is very similar to the ones up here. So number 7, it says a rectangle has an area of 2x to the 7, y to the 8, and a length of 6x to the 3rd, y. Determine the width of the rectangle. So this is one of those problems that a lot of people want to actually find the area, because they're like, oh yeah, I know how to find the area of a rectangle. It's length times width. So they want to do length times width. But it doesn't tell you to find the area. What does it actually tell you to find? It says find the width. So if you know area is length times width, you have to work backwards to find the width, which is the opposite of times. Divide. So when you divide, you want to put whatever the area is. So to find the width, you're going to have the area on top divided by the length that they give you on the bottom. And there's going to be a pause, and then through this video there's going to be a whole bunch of pauses. So if there's a pause, just wait, and then so if you want to find the area, if you want to find the width, the area is 12x to the 7, y to the 8 over 6x to the 3rd, y. And this looks like a division law. It's the dividing laws of exponents. The laws of exponents division, which means you do divide the coefficients, but you do not continue dividing these little exponents. You subtract the exponents. So 12 divided by 6 is automatically a 2. So it can't be A, can't be C. Then for your x's, 7, the power of 7 is on top, power of 3 is on bottom. We want to subtract those. Then the y to the 8, y to the invisible 1, that's 8, take away 1. So it gives you y to the 7. So you should clearly see your answer on that one. If not, you're going to have to rewind the video and look again, my friend. Okay. So from number 7, I'm going to go to number 10, because notice number 10 has that little fraction line, fraction bar, whatever you want to call it. Once again, this is dividing laws, and we just wrote it on the other one. Divide the coefficients, but you subtract the powers. However, notice that some of these powers have negative signs already. So make sure you're actually putting the subtraction sign in between. So first of all, we got 12 over 4. Those are the coefficients, so we need to divide. 12 divided by 4. 12 divided by 4 automatically gives us a 3. So a coefficient of 3. So does this have a coefficient of 3? No. Does this have a coefficient of 3? No. So now for my p's, I'm going to do 6 minus 3. Then for the q's, well, there is no other q's, so q to the 2 is going to stay at the bottom. So we want to make sure that there is a q to the power of 2 at the bottom, because there's no other q, so q to the 2 has to stay at the bottom. However, if you're looking at the r's, that would be a negative 8 subtract a what? A negative 3. And you could put that in the calculator if you needed to. Negative 8 subtract negative 3. And you'll see what that one is. And the answer looks like, notice what I said about the q. That q to the second power is the only q in the problem, the only variable of a q. So it has to stay where it is, as long as it's a power of positive. Okay? So you should see your answer on that one. If not, then you need to rewind the video and watch it again and listen carefully. Those are the 2 division problems. I don't know if there's any more division. So moving to number 9, because this one is clearly not a division problem because it doesn't have the division bar. This is a multiplication rule. So for the multiplication rule, we multiply the coefficients, but we do not multiply the powers. We need to add the powers. So the coefficients would be 20 and 5. 20 times 5, that gives us 100. So we know so far we have a 100. For my x's, I'm going to add, there's only one thing that has an x, so that stays like that. For my y's, I'm going to add -2 plus 7. Then for my z's, I'm going to add 1 plus -3. If you look at your answer choices, there's only 2 of them that actually have a coefficient of 100. Look at your x. Notice this x variable is the only one that has a x. So you better have an x to the 4 in your problem. Does A have an x to the power of 4? No. Nope. So D looks like the answer. However, it's kind of, well, let's keep going here. So this is going to be 100x to the 4. Then if you add this, you have y to the 5. Then when you add this, you have z to the 1 plus -3, that's -2. So we gotta, the rule for the negative is it can't be left in our answer. Everything else stays on top, divided by, now that's z to the positive 2 because I had to move it to the bottom. Remember, this z right here, that's an invisible 1z plus -3. So if your variable does not have a power on it, there's an invisible power of 1 on it. So that one, if you didn't get the answer, rewind the video. And I'm not going to keep saying that. So if you did not get the answer, make sure to rewind the video. That's the last time I'm going to say it. All right. So now moving to number 6, because Kimberly incorrectly simplified this expression. And this is a multiplication problem. There's no powers on the outside of the parentheses, so we don't have to worry about that yet. And got this answer. Which of the following is the true statement that best describes her mistake? So first, the way to do these mistake problems is to actually do it yourself and then see what she did wrong. So starting out with the coefficients, we need to multiply -5 times 4. Then for the g's, I'm going to add 3 plus 7. Then for the h's, I'm going to add 7 plus 9. So if I do the multiplication, that's -20. That's g to the 10 and h to the 16. So what is wrong? You have to look at, see what's wrong with her answer compared to mine. It looks like she does have g to the 10 and h to the 16, but something's wrong with the coefficients. Something's wrong with the coefficients. So she incorrectly combined the exponents. No, she did the exponents correctly. She incorrectly combined the exponents of h. No, she did those exponents correctly. She added the exponents when she should have multiplied. No, you're supposed to add them. But she actually added the coefficients when she should have multiplied the coefficients. That's what she did wrong. She took the coefficients and she added them together to get a -1. But she should have multiplied those coefficients. Okay? On to number 15. Which expression has a value of 1? I would hope that you would remember the rule for if you take anything to the 0 power. Anything to 0 power. And remember, you can use your calculator to check that one. You can put in like 100 to the 0 power equals what? 50.59 to the 0 power equals what? You can even do a fraction to the 0 power. And you will see that that's going to have the value of 1. So it's anything to 0 power. And we are going to continue by this problem 16, just because we just did 15. Now let's do 16. Bacteria can multiply at an alarming rate when they increase by 2% each day. If we start with only 3 bacteria, which exponential equation best represents the scenario? So there's a couple different ways you can go about this one. If you like using answer choices, you can use the answer choices by either writing growth or decay. Maybe I will give some extra credit if by each of these, when you see an exponential function, you need to write either growth or decay for extra credit. So looking at this one, when you're taking the test, you're like, is that growth or oh, Miss Ward said you can get extra credit if you write down growth or decay by each of these. So for this one, I'm going to write what? Decay. Then next to this one, I'm going to write growth because it's adding the one. For this one, yeah, we'll do that. This one, you get, what is it? Growth or decay? It's decay because the rate is less than 1. And this one is growth because the rate is greater than 1. So if you read the problem, you should be able to eliminate 2 of these because the problem should tell you whether it's increasing or decreasing or growth or decay. However, the problem is increases by 2%. 2%, remember the rule. If it's 2%, you have to then change the 2, whatever the percentage is, into a number that's actually a rate, which is no longer a percentage. So you have to move the decimal to the left 2 times. So if the decimal right here is always on the right, if you don't see a different decimal, it's always on the right, you move it to the left 2 times. So your problem will look like, now your percentage is this. And since it's increasing, now we add the 1 to it. So it should be 1 plus 0.02 to the power of x. Or remember, it could also be written as 1.02 to the x. And the other thing you probably need to check and make sure is the starting bacteria of 3. But all of them have 3, but I'm saying it just in case the test is different. All right? So you're looking for a rate of 1.02 or 1 plus 0.02. Okay? All right. So the next one, it looks like we're moving to 24. I would say 24 looks like one very similar to the one we just did. You spent $140 this month. Each month your spending habits will increase 11%. Write an equation to represent how much you'll spend each day. So you spent $140. That's the starting amount, the initial value that you started off spending. Then it says each month your spending habits will increase 11%. We cannot use 11% and say, oh, the B equals 11. No, we can't because it's a percentage. So remember, right now the decimal is back here because there's no other decimal. We got to move it to the left 2 times. So now it's 0.11. But don't forget that our habits will increase. So that means we got to do 1 plus 0.11 to the power of x to find our rate, which is our rate, should I say. Or it could be 1.11. That looks like a time. Sorry, the point should be more like down here. Now it looks like a clock. It should be 1.11. So when you're writing your equation, your rate that we would write in our equation is 1.11 or 1 plus 0.11. So the equation would be the function equals 140 times 1 plus 0.11 to the power of x. Any questions? Is there any more like that on the front? This one's kind of similar, number 13. Myra's savings account balance can be determined by this equation. What does the 3,000 represent? The 3,000, does it have the power on it? No, so it's not the rate. So the annual interest rate, no, the 3,000 does not represent the rate. The amount of interest earned, no, that's not it. The number of years since Myra opened the account, no, your X would actually represent the years if it was time. Or the starting balance of the savings account. Remember that value, that A value is the initial value or the starting value. And you'll have to watch part 2 of the video because I got to stop it because it's almost at 15 minutes.